Back to the chapter 6.5 notes, the very last page, trigonometric functions of general angles. You will notice quite a few problems like this in the homework. So let's figure out how to tackle these. So example 12, the cosine of t, so we're not using theta here, we're using t, same thing, is 2/9, and t is in quadrant 4. So the first thing I'm going to do is draw my picture. Does not have to be super precise, but it told me t's in quadrant 4. Okay. Cosine is 2/9. So cosine is adjacent over hypotenuse. So I'm going to use that piece to label two of the three sides. Now, if it's a unit circle, you guys, that's fine. My hypotenuse is going to be 1. My cosine is going to be 2/9. They're all ratios. They're all relative. But we need to find the value of sine, which means I need to figure out what the length of this side is. Okay. So I have a right triangle. There's my a squared. Plus, we're just going to leave it a question mark, equals 9 squared. I get 4 plus whatever we're trying to find is 81. So the length of our side squared is 77. That length of that side is square root of 77. Now, keep in mind, I am in quadrant 4, so my sine has got to be negative. From my x-axis, I go down square root of 77. So the value of sine of t, negative square root of 77 over 9. Keep in mind, we want this written as a fraction. My y-coordinate has got to be negative, so my sine is negative in quadrant 4. And if we wanted an ordered pair, I don't want to write 2/9 because it shows over 2 and 9, so I'm not even going to put that in there right there. But orient, figure out which quadrant it's in, figure out where the reference angle is and what the triangle looks like, and then you can find your other values. Let's get out of this dark blue. Sine of t is 2 over 13, and t is in quadrant 2. So again, quadrant 2 is over here. Here's my reference angle t. If sine is 2 over 13, that's opposite over hypotenuse. I can label those two sides of my triangle. Okay. We want tangent, so I need to be able to find that adjacent side. This time I'm going to go ahead and call it x. Realized my question mark looked kind of like my 2. No reason to make anybody confused. Oh, 165, 5 goes in there? 33 times, 5 times 3 times 11, so I do not have a perfect square. So when I square root both sides, I'm just going to leave this side as square root of 165. Okay, equals square root of 165. Again, we are going to the left, so my cosine's got to be negative. So then my tangent of t is opposite over adjacent. Again, not going to leave that radical in the denominator. And I'm also not going to leave my negative in the denominator. I'm just going to pull it out front. 2 square roots of 165 over 165. Example 14, find the lengths of the missing sides if side A is opposite angle A, side B is opposite angle B, and side C is the hypotenuse. Hypotenuse is always opposite our right angle. So here's my triangle ABC. Little a is opposite angle A. C is my hypotenuse. Little b is opposite angle B. It says the cosine of B here is 21 over 29. So cosine adjacent, 21 over 29. There is our ratio. But you guys, it says A has to be 30. Okay. So if my ratio is 21 over 29, but A has to be 30, let's see if we can solve for that. First thing I'm going to do, though, is flip these over just so I have my x in the numerator. It's a ratio. I can flip over both sides. I am then going to multiply both sides by 30. So I can solve for x. 3 goes into 30 10 times. 3 goes into 21 7 times. I have got an x, or my c, actually, I guess I should have just labeled it c, is 290 over 7. That's not fabulous, but we can work with that. So A is 30. C is 290 over 7. So how many times does 7 go into 290? Let's see, 41. So this is actually 41. And what do we have left over? 3? 41 and 3/7? That's kind of gross. All right. But we can find the length of B at this point. Keep in mind, cosine of B is 21 over 29. I can use that to label that sides, but that is a ratio. If A is actually 30, then we can figure out the actual lengths of the sides. Numbers not quite as nice and neat as we're used to here. How about we go to 2 places? And I'm writing really big. When we square root both sides, okay. I saw a homework problem like this somewhere, but I am not convinced that this is in this section. So this is an example that you can gloss over unless you get stuck and you want a little more help. And actually, since the other one's a fraction, I might as well make that one. Okay. But this one's I'd go over that quick and then just come back if you need it. But I know that example 15 is exactly like what you see in the homework, because I'm pretty sure I lifted this from my homework. Okay. We want the value of cotangent of theta if secant of theta is negative 6 over 5 and tangent is greater than 0. So tangent is greater than 0 means we're either quadrant 1 or 3. If secant is negative, secant is 1 over cosine. If this is negative, we got to be in quadrant 3. Okay, so here's my angle, somewhere down here. Again, I'm not worried about whether the lengths of my sides are correct. I can label them. Cosine is adjacent over hypotenuse, or length of the adjacent side over length of the hypotenuse, which means our secant is length of the hypotenuse over length of the adjacent. So my hypotenuse is 6. Keep in mind my hypotenuse is always positive, which means the length of my adjacent side is -5. Okay, or let me rephrase. The length of the side is 5. It's going in the negative direction. Okay. We want the value of cotangent, which is adjacent over opposite, so I need that opposite side. I got 5 squared. We'll call it y. Y squared, 36 minus 25. So I got square root of 11. The length of the side is square root of 11. I'm going in the negative direction, so I'm going to put negative square root of 11 there just so I remember. Okay. Cotangent of theta is x over y. My x is -5. My y is negative square root of 11. We're going to rationalize that denominator. Remember that I am multiplying by, I'm dividing my negative by a negative. So I end up with a positive answer. No radicals in the denominator. 5 square roots of 11 over 11.